two-step formulas. Solving formulas, we will treat other variables like numbers before we actually start to solve. So in this example, so we've done this before where we have 3x is equal to 15. So all we have to do is then just divide by 3 on both sides. So this just becomes a 1, so then it's really just x. So 15 divided by 3 is then 5. So x is equal to 5. So we've done this before, but now we're going to look at it in a different way. So we have wx is equal to y. Well, let's solve for x. Well, all we have to do to get rid of w on the other side, we just divide like we've done before, because that's multiplication, so we do the opposite. Then we just get, this just becomes a 1, so then we just have x on this side, which is equal to y over w. So this would be represented, like, say, as an expression. And then we can go ahead and plug in our numbers after we've done this. So let's go ahead and look at some examples. Example 1. A ball drops from a plane and accelerates towards the ground at about 9.8 meters per second squared, which is our A. And also remember, when we have m and then s with a -2, that means if we put it in the denominator, it becomes positive. So let's continue on. So after 3.5 seconds, which is our t, it hits the ground at a velocity, which is our v, of 37 meters per second. First, find the speed of the ball u when it just left the plane in terms of the other variables. Second, find the speed of the ball, the u, by then using the numbers given in the problem. So our problem is asking us to find u in terms of the other variables first. So let's go ahead and do this like we've done this before. So we have v equals u plus at. Well, let's go ahead and just rewrite this. Well, we want to get u by itself. So all we would do then is go ahead and subtract at on both sides. Since we don't have then at, we would just leave it like -at all by itself right there. Then let's go ahead and rewrite this. We have -at plus v is equal to u. Or if you want to switch these, you can go u is equal to v minus at. So that's how we would rewrite this in terms of just the variables. So this is step 1. Now let's go ahead and plug in our numbers. So u is equal to, what's our v? Well, let's go back. Our v is 37. So we just go ahead and just write the numbers. So we have 37 meters per second, and then we have go minus, then we have a 9.8, which is our acceleration, because it tells us right here, accelerates towards the ground at 9.8. So we just go ahead and write 9.8 right there. And then we have t, right? So we need to go ahead and plug in t, which is then, when we look, 3.5 seconds. Now we can put all of these in parentheses. Then let's go ahead and solve. So we have 9.8 times 3.5, which is 34.3. So this becomes 34.3, because we did the multiplication first. Then we write 37 here. So now u is equal to 37 minus 34.3. So let's go ahead and go 37 minus 34.3, and we get 2.7. And this is for velocity. So we can go meters per second. So this is our answer if we solve for it with an actual number. And this is how we solve for it with the other variables. So now let's look at another example. So a ball drops from a plane and accelerates towards the ground at about 9.8 meters per second squared, with an initial velocity, which is u, of 0.25 meters per second. After t seconds, it hits the ground at about 44 meters per second, which is our v. First, find the time it took to hit the ground in terms of the other variables. Second, find the time it took to hit the ground by then using the numbers given in the problem. So let's look at our equation. So we have v equals u plus at. So we are first solving for just t. So how would we go about this? Well, let's go ahead and rewrite this. Well, we always start with addition and subtraction first. So we see that a and t are together, so we would leave that first by itself. So the first thing we're actually going to do is go ahead and subtract the u from both sides. Then this becomes 0. And then on the left-hand side, we're left with minus u plus v, which is equal to 0 plus at. So we've done our addition or subtraction first, because we're trying to get t by itself. So we first move the other variables first. Then, since we have at all by itself on the one side, let's get rid of the a. And how we do this is we just go ahead and divide on both sides. So this just becomes a 1, so now we just have t. And then we go ahead and divide both of these by a. So there's two ways you can do it. You can leave it at like this, where you just go ahead and divide by negative u plus v all over a, or you can go like this. Now, both of these mean the same thing, so let's also show this, or you can show it as t is equal to negative u plus v over a. This is the same thing. So now let's go ahead and now plug in our numbers. And I'm going to use this one. And if you want to verify this is the same thing, you can just plug in the numbers and make sure you got the same number for each one for t. So let's go ahead and start solving. So let's go ahead and rewrite it right here. Okay, so the first things we have to find, let's find u. We have first, or we can actually just go by the problem. So let's go find 9.8 meters per second squared. So let's go ahead and write 9.8 on the bottom, because that's our a, because it has to do with acceleration. Then we have initial velocity, which is our u. So we have negative 0.25 meters per second plus, and then after t seconds hits the ground at 44 meters per second. So that's our v. So we go ahead and put those in parentheses, and then let's go ahead and solve for t. So get our calculators out. Let's go ahead and add. So we have negative 0.25 plus 44, which is equal to 43.75 for the top. Then we can go ahead and then divide it by this 9.8, because we are looking at now 4.464, and then continues on. So let's just round to the nearest hundredth, which would then be 4.46 seconds. So now we solved for t first in the expression, and then we solved for it actually in t by using the formula that we found.